This is the 310 to 311 review. Number 6, calculators are not allowed. And in this case, we are given a chart of data, some information, and we want to use it to approximate function outputs. So that means we're going to be using linear approximations. We will create tangent lines that we can plug the 0.2 or the 3.1 or the 2.3 into. So our goal is to come up with tangent lines that are going to have tangent points, or the center of the linearization, which is closest to these values. So with part A, we're interested in approximating the function output at 0.2. So we need to choose a center that is close to 0.2 that we have information on. So if we look up here at the list of possible x's, the one that's closest to 0.2 is 0. And remember, we're going to do a linear approximation, so that means we're going to be doing a tangent line approximation, which means that we need a point and we need a slope. So the point is going to be the x-coordinate of 0 with its output on the function, which is 3, and the slope will be f prime of 0, which again I can get out of the chart as a 1. Once I have the point and the slope, I can put them together in the linearization and get the slope times x minus the x-coordinate plus the y-coordinate. Now our goal is to approximate the function output, so we're going to say that the output of the line is really close to the output of the function. So that means the function at 0.2 can be approximated by the output of the line when I plug 0.2 in. So I'd have a 1 times a 0.2 plus a 3. And I don't have a calculator for this, so chances are good that on the test you will have the answers look exactly like this. Might be simplified, I can't remember, but we could simplify very readily and get a 0.2 plus a 3 and be done. If we look at B, same process. We need to choose a point that is close to 3.1 that we have information about. So looking at my options for x, 3 is there and 3 is close to 3.1. So the point that I will use is the point with an x-coordinate of 3 and a y-coordinate of 8.5. The slope that I will use will be the derivative evaluated at 3, which we again can get from the chart, is a 6.25. Once we have the point and the slope, we can write the linearization that will approximate values for the function that are close to 3 by using the slope times x minus the x-coordinate plus the y-coordinate. We're interested in evaluating f of 3.1, so we will get close to it by looking at the output of the line when I plug a 3.1 in for x. So I have a 6.25 times a 0.1 plus an 8.50. Last one, C. We're using the same chart of data, only we're looking for points that are close to 2.3. So on C, again, the point in this list that's closest to 2.3 is the 2. So the point I will use is 2, 6.15, and the slope that goes with it, f prime of 2, is going to be 4.45. Put the two together, we can write the equation of the linearization, which will approximate that curve, and then use that approximation, or excuse me, the linearization to approximate the output of the function at 2.3 by plugging 2.3 in. So I'll have a 4.45 times a 2.3 minus a 2 is a 0.3 this time, plus an plus a 6.15. Sorry, it's going to the wrong point. And we're done.